Next, IoT enabling technologies. Here, IoT enabling technologies according to the syllabus here, we have wireless sensor network, cloud computing, big data analytics, communication protocol, and embedded system. So these are the according to the our syllabus. We have different many more like artificial intelligence and machine learning, data science, cyber security. We have many more IoT enabling technologies are available, but here according to the our syllabus, just we mentioned here wireless sensor network, cloud computing, big data analytics, communication protocols, and embedded system. So these are the let's start with the first one, wireless sensor network. So here, before going to entering that wireless sensor network, first what is sensor, what is the meaning, what is the meaning of specification of wireless sensor network, like that. So here the sensor is a device, a module or mission or subsystem whose purpose to detect the events or changes in environment and send the information to the another electronics. So that is the main purpose. Sensor always used with the other electronic devices only. Simple instrument model, that is the temperature sensor, humidity sensor, proximity sensor, light sensor, metal sensor, and color sensor. So these are the different types of sensors. Next, wireless sensor network, it having some different challenges here. Comprises of distributed devices with sensors which are used to monitor and the environmental condition. And weather monitoring system, this is one of the challenge also. Weather monitoring system, indoor air quality monitoring system, soil moisture monitoring system, surveillance system, smart grid, and structural health monitoring system. So these are the different challenges under wireless sensor networks. So weather monitoring system is in which nodes collect temperature, humidity, other data which is aggregated and analyzed. So that is the weather monitoring system. Next, air quality monitoring system to collect data on the indoor air quality and concentration on various concentration of various gases. And soil moisture monitoring system to monitor soil moisture at various locations. And surveillance system, it uses wireless sensor network for collecting surveillance data for is nothing but motion data detection system. And smart grids, it uses wireless sensor network for monitoring grids at various points, like that is the smart grids. And structural health monitoring system, we use to monitor the health monitoring or structure by collecting vibrations from sensor nodes to deployed at various points in the structure. So these are some challenges from wireless sensor network. So here this is the diagram of wireless sensor network and the sensor node architecture here. So here this is the just internet point. He is the user, and sensor nodes available at different points. This is the target. So here the main block diagram contains here position and finding system, mobilizer. Under position and finding system, just we use sensing unit, processing unit, and transmission unit. So transceiver, processing or storage, sensor ADC, power unit or power generator. So this is the just diagram of sensor wireless sensor network. So here I have the power, distributed communication, computing, and sensing features. They are characterized as infrastructure, less fault tolerant and self-organized network, which provide opportunities for low cost, easy to apply, rapid and flexible installation in the environment for various applications. So this is about the some points under revision of IoT enabling technology. So what are the characteristics of wireless sensor network here? Resource constraints and communication paradigm, application specific design, and node failure, unreliable communication. So these are the some characteristics of wireless sensor network. Under resource constraints, just we get the power from the batteries. It adjusts the service provided by the nodes, like communication, and communication amount memory is very limited. And communication paradigm, the data centric feature of wireless sensor network explain its data centric nature and justifies the that the communication is restricted to nodes. And application specific domain, WSN is application specific, that is architecture of wireless sensor network is based on the application. So node failure and reliable information, any one of the node is failed, based on that the entire system will collapse. So these are the characteristic of wireless sensor network under revision of the IoT enabling technologies. Next, scalability, density, dynamic topologies, and communication models. So these are the number of nodes in the wireless sensor network may be large and densely deployed to a higher degree in various applications. And nodes are free to travel randomly at different speeds. A few applications and sometimes may fail to operate. To add or replace, though, they can be different network topology. The communication models. We use different communication models like hierarchical distributed wireless sensor network, or homogeneous or heterogeneous wireless sensor network. So these are the some characteristics and requirements of wireless sensor network here. Flexibility, fault tolerance, lifetime. Flexibility is nothing but rather it varies from application to application, which justifies that the protocols and algorithms have the characteristics of self-organization. Fault tolerance, the nodes in the wireless sensor network have the capability to sustain the functions carried out in the network. And lifetime, two major facts that should be taken into consideration are load balancing and energy. Load balancing and energy. Scalability, real time, and security. Also, requirements of the to install the wireless sensor network. The number of nodes in wireless sensor network to be large according to the net architecture. The protocol should be designed. So, real time. The various capabilities like sensing, processing, communication of the wireless sensor network are used in various real world problems should be followed the stringent time. Security, for example, healthcare data, the military data, the data offered by wireless sensor network are private, which more it is more secure than normal secure. So that is the scalability, real time, and security. Production cost, deployment, and dependability. The cost of the nodes in wireless sensor network has to be low as once the nodes run out of the energy, and it has to be replaced by the newer nodes. That is the production cost and deployment dependability. And cloud computing overview. So the according to the I mentioned the first slide, we have five types of enabling technologies: wireless sensor network, cloud computing, big data analytics, communication protocols, and embedded system. So the first one is wireless sensor network is over. Next, cloud computing overview that continue with the next lecture. Thank you. Hello everyone, this is Prashanth. In the last lecture, just I have completed IoT enabling technology. So here we have five types of wireless sensor, wireless enabling technology. So the first one, wireless sensor network, continue in the completed in the last lecture. So now we move entering into the cloud computing, big data analytics, communication protocols, and embedded system. So these are the remaining four IoT enabling technologies here. So the start with cloud computing here, the cloud computing overview. So here, before going to that, so what is cloud computing? What are the storage models and deployment models available in the cloud computing here? So the cloud refers to a network or in internet. In other hand, we can say that the cloud is something which is present at the remote location. The cloud can provide services over public and private network, that is WLAN, wireless local area network, um, local area network, virtual private network, like that. The cloud computing refers to manipulating configuration, accessing the hardware and software resources remotely. It offers online data storage, infrastructure, and application. So this is the just to complete overview of the cloud computing. The storage, application, infrastructure, it can provide the space to the store our information. That is the meaning of cloud base basically. So here the next one, cloud computing concepts are here. We have two models, deployment models and service models. So entire cloud computing depends on these two types of models, deployment models and service models. The deployment models having four types here. public cloud, private cloud, community cloud, and hybrid cloud. So here the public cloud is nothing but open to all. So that is the it may use to anyone. And private cloud, it is particular one organization or one company or particular one government, like that it can private. And community cloud, so it is used for the community. It allows the service access by a group of organizations. So that is the main important point, that is the cloud, community cloud. And hybrid cloud, so it is the combination of public and private cloud, that is under hybrid cloud. So this is the diagram of four types of cloud access under deployment models. So here next, service model is very important topic also in the revision of IoT enabling technology. So the cloud computing service models are here: infrastructure as a service, platform as a service, software as a service. So here service as a server, it is for end users. Platform as a service for application development, just you can based on the application. And infrastructure as a service is nothing but network architecture. So it is three types of service models: infrastructure as a service, shortly IaaS; platform as a service, PaaS; software as a service for SaaS. So let's start with the first one. Infrastructure as a service provides the users to the ability to provision computing and storage resources. That is the main aim of infrastructure as a service. And virtual resources provision by the users be built based on a pay per use paradigm. So how much you can use the memory, for that only you have to pay the amount. So it is, it include uh, cloud infinite, private cloud, and hybrid cloud. So this is about the infrastructure as a service. So here infrastructure as a service provider provides the following services to customers, like compute, storage, network, and load balancers. So here under compute, just we use it includes virtual storage processing units and virtual main memory for the VMS, that is provisioned to the end users. And storage, IaaS providers end back storage for storing files. Network as a service provides networking components as such routers, switches, and bridges for the VMS. Load balancer, it provides the load balancing capability at the infrastructure layer. So these are the four IaaS provider services: compute, storage, network, and load balancers. So advantage, shared infrastructure, it allows and web access to the internet, pay as per use model. So how much you can use, for that only you have to pay. For example, 12 GB of data I am using. For that 12 GB of data, how much cost it will be, you can pay for that amount only. And function on the core business. So IaaS provider focus on the organization's core business rather than on IT infrastructure. And demand and scalability. Demand and scalability is one of the biggest advantages of IaaS. Using IaaS here, demand and scalability. So these are the advantages of IaaS. So here the disadvantage in terms of security, maintenance and upgrade, interoperability communication. So interoperability communication is nothing but just you can other company remote, just we can use other company AC or TV or whatever, just home appliance available in our home. So these are the disadvantages of IaaS. And these are the top providers who are the providing IaaS cloud platform, cloud computing platform, starting from Amazon Web Services, NetMagic Solutions, Rackspace, Reliance Communication, CP Technologies, and Tata Communications. Next one, PaaS, that is the stands for Platform as a Service. It provides a runtime environment. It allows programmers to easily create, test, to run, and to deploy web applications. So that is the main specification of Platform as a Service. So here examples: Google App Engine, Force.com, Joet, and Azure. So here purpose, abstraction, and functionality. The platform as a service run based on these three main factors, that is purpose, general purpose, emerging specialized technologies, and functionality. Under functionality, deployment, automation, infrastructure, measurement, content, orchestration, and application, low, moderate, and high. Whether it is low, whether it is moderate and high, whether it is high abstraction. So this is the figure of platform as a service. So service providers to us. So here programming languages, application framework, databases, and other tools. So here the programming languages, it provide various programming languages for the developers to develop the application. For example, it provides Java, PHP, and Ruby, Perl, and Go. Application framework, it provides the application framework to easily understand the application development like Node.js, Drupal, WordPress, Spring, Pay, Rock, and Gen. Database, so it can provide some database also. Other tools, the PS provider various tools that are required to develop, test, and deploy the applications. And advantage, so here simplified development, lower risk, pre-built business functionality, and instant company. So these are the some advantages which provided from the platform as a service. Next, to disadvantage of platform as a service, vendor lock-in period is very low. Data privacy, it may have some concern, and integration with the rest of the system applications. So these are the just we are facing some disadvantage from the platform as a service. And top platform as a service providers who are providing IaaS cloud computing platform. So that is starting from Google App Engine, Salesforce.com, Windows Azure, AppFog, OpenShift, and Cloud Foundry from VMware. So these are the some providing IaaS cloud computing platform. And just in terms of table here, Google App Engine, like this type of services it can provide for us: app identity, URL fetching, cloud storage, client library, logistics service like that. Salesforce.com, faster implementation, Windows Azure, AppFog, OpenShift to Cloud Foundry from VMware, the data messaging and other services. This type of services just we discussed in the last slide only. And the next one, software as a service. So this is the revision part. Just you can assume, just you can identify the what the title, what are the lines in that explanation regarding that. Just you can identify the titles main in the revision part. So software as a service provides the user complete software application with the user interface to the application itself. So it is also known as on-demand software. It is a software distribution model in which services are hosted by a cloud service provider. So this is the software as a service program. Just it is based on this servers, database, codes. Database depends on the application. We can develop the application. So this is the software as a service. And service providers. So here business service, document management, social network, and mail services. It can provide services for us from the software as a service. Business services, document management, social network, and mail services. It can provide under business services. Just we can business services to start up the business. The SAS business services include ERP, enterprise resource planning, like that. Just we have to maintain. Next advantage is easy to buy and one to many. Just you can use one to many like multiplexing, and less hardware required for the software as a service. We already know software as a service. Just we can software it can serve the services to the users. So there is no need of any hardware components, and low maintenance required for SaaS. So here software as a service moves to the need for installation, setup, daily maintenance for the organization. To know the initial setup cost for SAS is typically less than enterprise software. And disadvantage in terms of security, some latency issue also, a total dependency on network, switching between SAS vendor is difficult. So these are the some disadvantages of using software as a service cloud computing. So these are the some top SAS providers who are providing infrastructure as a service cloud platform. Here, Microsoft 365 application. This is one of the software. Google App Engine also software. GoToMeeting, Constant Contact, Oracle CRM, NetSuite, Workday, Int, and Salesforce.com. So these are the some providers, top providers. And these are the service. Just we already know Salesforce, it can provide this type of services like on-demand CRM solution, and go-to-meeting also, online meeting and video meeting conferences like Google Meet, Zoom, um, WebEx like that. The Workday also human capital management, payroll, and financial management. So these are the about the cloud computing service models and explanation. And next big data analytics. So here the big data analytics refers to the methods, tools, and applications used to collect, process, and derive insight from varied high volume and high velocity data sets. So this is the about big data analytics. Just it is the variety of resources it uses, such as web, mobile, email, social media, and networked smart devices also. Some examples of big data generated by IoT system here. The sensor data generated by IoT systems such as weather monitoring system, like the first one based on the big data analytics. Data generated by IoT system for location and vehicles, and data generated by retail inventory monitoring system also. So these are the revision on big data analytics and the part of revision of IoT enabling technologies. So here use cases, risk management, product development and innovation also one of the use case here. Bantoti Euro Philips banking company uses big data analytics to identify the fraudulent activities and discrepancies. So this is the use case of risk management under big data analytics. Next one, product development and innovation. Rolls-Royce company, one of the largest manufacturing company, it uses big data jet engines for airlines and armed forces across the globe. It uses big data analytics to analyze how efficient the energy designs are, if there any need for improvements. And the benefits and advantages of big data analytics here: quicker and better decision making within organization. That is one of the use case. The first one, for example, the company leverages it is to decide if a particular location would be suitable for a new outlet or not. And improved customer experience use cases. Delta Airlines use big data analytics to improve customer experience. So these are nowadays we are using so many benefits of big data analytics to use our projects, own projects. Characteristics of big data here V3. Volume provides the amount of data, how much amount of data and the form of data. Velocity, it provides the time at which the data is collected and analyzed. And variety provides the type of data collected. That is these three: volume, velocity, and variety. These three of characteristics of big data. Volume, so there is no fixed threshold for the volume data. It is used for massive scale of data. The first one. Second one, velocity is another important characteristic of big data. It is the for exponential growth of data. The velocity of data refers to the fast the data is generated. So that is the purpose of velocity here. And variety. Variety is different from such as structured or unstructured data, including text data, image, audio, video, and sensor data. So these are the main characteristics of big data: volume, velocity, and variety. Next, we have four types of big data analytics here. Descriptive analytics use cases. So descriptive analytics, diagnostic analytics, predictive analytics, and prospective analytics. So start with the descriptive analytics. Just it summarize the past data into the form that people can easily read. This can help to create reports like a company's revenue, profit, sales, and so on. Like that, this is descriptive analytics. The second one, diagnostic analytics. Here, it is main used to understand the what caused a problem in the first place. The techniques like drill down, data mining, and data recovery are the examples of the diagnostic analytics. And the next one, predictive analytics. Here, the using predictive analytics, the company uses all the historical payment data and user behavior data and builds an algorithm that predicts fraudulent activities. So that is the next one. So the last one, perspective analytics big data. So here this type of analytics performance is the solution to a particular problem. Perspective analytics works with both descriptive and predictive analytics. So use cases, it is maximize the airlines profits one of the company. These are the some kinds of big data analytics, descriptive, prescriptive, perspective analysis. So these are the some key analytical tools of big data. Hadoop, uh, MongoDB, which type of it is uses, Talend, Cassandra, Kafka, Sparks, and Storm. Big data analytic tools. And big data analytic industry applications like e-commerce in every domain, almost marketing, education, healthcare, media, and entertainment, in banking, telecommunication, and government. So big data analytics helps to government in law enforcement, among other things. So these are the some industry applications of big data analytics. So the last but one, that is communication protocols here. To define the these protocols define the data exchange formats, data encoding, addressing, sensor for devices, and routing of packets from source to destination. So here we have different communication protocols that allows to exchange the data over the network, like JetWave, Bluetooth, Google Thread, Wireless Path, NB IoT, LoRaWAN, and significant Sigfox. So the next one, embedded system here. The ideal structure of embedded system here, by using software, just we can by using software we can design the hardware parts, or the embedded system defines it is the combination of hardware and software with mechanism. Just we have to build one microcontroller board, just to some software program build on that microcontroller. So that the combination of that, just it is also known as embedded system board, like that. It has embedded system is a computer that has computer hardware, software to perform specific tasks with mechanism. And key components of embedded system is microcontroller, microprocessor, memory, RAM, cache memory, networking units, input output units, and storage. This is the ideal data device able to communicate through over the network, other device to the internet, embedded system device by using communication protocol, Wi-Fi, Bluetooth, Ethernet, Zigbee, and ideal local network, LAN, WAN, MANET, verified hardware device, sensor activated hardware devices. This is the aerial idea view of embedded system. And hardware, embedded system hardware, same diagram here. And these are the embedded system uses some device for the operating is based on that language platform, mainly where the real-time operation would be performed, manufactured, build embedded software in electronics. Examples: cars, telephones, modern appliances, etc. Embedded system software can be simple as lighting control running using 8-bit microcontroller. It can also be complicated software for missiles, process control, and appliances. So this is the embedded system. These are the several references I used for this lecture. Javapoint.com, tutorialpoints.com, or Geek for Geek, some research papers, SCI or Scoopus paper also I referred for this lecture. This is also one of the software defined generator based cloud computing techniques also. These are the references. So remaining continue with the next lecture. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.